Good morning, afternoon, or evening, everybody. Welcome to the Data-Driven Storytelling Using an Atmospheric Data to Share Your Science Earth Data webinar. This is your host, Jennifer Brennan. I have 2 p.m. Eastern Daylight Savings Time, so let's go ahead and get started. First, what I'd like to do is go over some webinar logistics. To ensure the best audio experience, participants have been placed in silent mode, but if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earth Data YouTube channel within a couple of days of completion. Once completed, I'll send an email to all registrants with both of the recording links. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and demonstration and an additional 15 minutes for the question and answer period. Our speaker today is Dr. Danielle Grumman. She is the science lead for NASA's Atmospheric Science Data Center Distributed Active Archive Center, or ASDC DAAC. And I'm going to pull up today's agenda for everybody here. All right. She will begin today's webinar with an introduction to the ASDC DAAC, and then from there we will transition to several demonstrations that will include a demo of the NASA Earth Data Forum, a quick tour of the ASDC's new website, and a MISR data demo using Jupyter Notebook. After our speaker is finished with her presentation, what we'll do then is we'll move to a final optional set of polling questions. Generally, we'll give these questions about 3 to 4 minutes or so, and then from there, we will transition to the Q&A directly. Depending upon the volume of questions that we receive, we'll extend the Q&A period an additional 15 minutes from end time for those of you who wish to stay on the line, but we do have a hard cutoff of 3:15 p.m. Eastern Time. With that, it is my pleasure to introduce today's speaker, Danielle Grumman. Danielle?
Thank you, Jennifer, very much, and hello to everyone out there. I hope you can see my screen okay. Thank you, Jennifer. Thank you for joining us today. On behalf of NASA's Atmospheric Science Data Center, we are excited to share some new resources we hope you will find useful. The format we are using for this presentation today is a bit different than traditional presentations. We decided to showcase our material through an Esri ArcGIS online story map. This is a tool which allows you to input ArcGIS online interactive maps alongside other traditional multimedia such as text, images, and videos, all in one easy-to-scroll-through location. Story maps are a great tool for outreach and a platform we use often here at the ASDC. Jennifer will be sending out the link to this story map later this week, so be on the lookout for that so you can explore the story map even more in the future. So what is the ASDC? The ASDC stands for the Atmospheric Science Data Center and is one of 12 NASA data centers. Last year, we reached 123,000 users in 184 countries. We stored over 5,000 terabytes of data and distributed over 800 terabytes of data to our users. We are your go-to place for NASA atmospheric science and meteorology data. What is a DAAC? The DAACs are Distributed Active Archive Centers. As you can see here in this map, the DAACs are scattered all across the United States. By clicking each one of these dots, you can see what each DAAC's area of expertise are, as well as access each center's website. Over here on the East Coast, if I zoom in, you can see where I work, the Atmospheric Science Data Center in Hampton, Virginia. Just as our name implies, we are a data center that specializes in housing atmospheric and meteorology-related data. As such, the ASDC has 4 main research areas on aerosols, clouds, tropospheric composition, and radiation budget. Aerosols are tiny particles suspended in the air, such as dust, pollen, and industrial emissions. Aerosols are studied by the instrument MISR on the Terra satellite, which we'll talk about later. Cloud properties such as cloud top temperature are studied by instruments such as Ceres, Calypso, and MODIS. Troposphere composition includes parameters like nitrogen dioxide, ozone surface mixing ratios, carbon monoxide, and particulate matter as seen by the instruments and satellites TESS, MISR, and MOPIT. And the study of the amount of incoming shortwave radiation from the sun versus the outgoing long-wave radiation from the Earth gives us what we call the radiation budget, which is studied by the instrument Ceres, for example. Like all NASA DAACs, the ASDC ingests, processes, archives, and distributes data from satellite missions and airborne campaigns that deal with our areas of focus. Scientists from these missions give us their data, we process the data and ingest it into our system, then distribute it to users to easily download and visualize their data of choice. Data products translate these findings into meaningful knowledge that inspires action by scientists, educators, decision makers, and the public. Now that you're more familiar with what the ASDC is and does, we'll dive into the main topic of this webinar. I'm going to walk you through a data discovery, download, and visualization workflow using some new web pages, tools, and services the ASDC has available using the research of the Australian wildfires disasters that happened this year as a case study, so that you too can use data to explore Earth. The Australian wildfires were not only devastating to the country, with over 27 million acres of land burned, but also negatively impacted the atmosphere as well. In this image, you can see these red dots represent the fires themselves. And this is all the smoke from the fires. While the case study we are presenting today is related to the Australian wildfires, we hope that you can apply it to your specific area of research or be inspired to start new research related to the wildfires. To start, we'll begin by talking about how you can learn more about NASA data by pursuing and posting in the Earth Data Forum. Here we have a diagram of all the Earth-observing satellites that NASA operates. Now, imagine all the data coming from these satellites. With more than 34 petabytes of data, thousands of data products, and a plethora of applications and tools for working with these data, it's impossible to know all the ins and outs for each. There's so many data, products, and services in NASA's Earth observing system of satellites. Fortunately, experts at the discipline-specific DAAC have the answers. This is the new Earth Data Forum, available at forum.earthdata.nasa.gov, and it provides a central location where data users can interact with subject matter experts from multiple DAACs to discuss general questions about research needs and data applications, and receive help on specific queries about accessing, viewing, and manipulating NASA Earth observing data. 5 of the DAACs we mentioned earlier on the DAAC map are currently participating in the Earth Data Forum. We've got the Atmospheric Science Data Center, where I work, the Crustal Dynamics Data Information System, the Goddard Earth Sciences Data and Information Services Center, the Global Hydrology Resource Center, and the Land Processes DAAC. Experts from NASA's Oak Ridge National Laboratory DAAC and the Socioeconomic Data and Application Center will join the forum later this year. The Earth Data Forum launched last month, and we are really excited to give you a walkthrough of this powerful new website. Here you can see the homepage for the forum. On this page, you can post a new question using this green button, type in keywords to search for posts in the search bar, or search by tags here. Posts are tagged by discipline, such as atmosphere, by the different DAACs, such as the ASDC, by major projects, such as Calypso mission, or by services usage such as data visualization. To get more information on what the definition of the tags are, you can click on what do these tags mean in the lower right of the second box. In the third and last box on the page, click All Questions Comments to see all posts that have been made on the forum, starting with the most recent. In the upper left of the page, there are 3 easy access links. Clicking on Quick Links, you can look at unanswered questions, active questions, search, or learn more about the NASA DAAC. If you click on the second button, FAQs, a filter will present all posts tagged by moderators that are general questions that users ask frequently. You can click the Home button to go back to the main page at any time. The third button on the top left is Data Recipes. This link will filter all posts that have been tagged as data recipes. There are usually step-by-step instructions on how to download and analyze data. Click back on the Home button to get back to the main page. So now calling back to our scenario of studying the Australian wildfires, let's walk through a use case for the Earth Data Forum. So let's say there is a graduate student who attended a conference recently where she saw an earth scientist present some cool visualizations of a wildfire event. She took some brief notes during the presentation, jotted a few keywords down such as wildfires and miser. She didn't even know what miser means, but she is fascinated by the presentation and inspired. So she goes back to her university after the conference and thinks about it some more. The student would like to create her own visualization, this time for the wildfires that burned in Australia from 2019 to 2020 using miser data. She starts with Googling the term miser and finds it stands for the Multi-Angle Imaging Spectroradiometer and is an instrument aboard NASA's Terra satellite. Okay, that narrows it down a bit. It's NASA data. At the conference, she also heard of the NASA's Earth Data Forum, so she figures that's a good place to start. Looking at the homepage of the forum, she knows that the scientists at the conference use miser data, so she navigates to Search by Tag feature, and she goes to Major Projects and chooses miser and hits Submit. She scrolls through the results for a second, but doesn't see anything relevant to her. So she decides to go back to the home page to try another search. She goes to the Services and Usage category and chooses Data Visualization. After a quick search, it looks like there's some wildfire resources, and it looks like there's a post related to the Amazon basin fires, which it could be relevant. She clicks on the NO2 emissions on Amazon basin fires, scrolls down. There looks to be some cool plots, but not exactly what she was looking for. So she decides to go back and checks out that wildfire resources post she saw at the top. This is interesting. It looks like it might be related, but not quite what she was looking for. So since the forum doesn't have any questions related to the Australian wildfires using miser data yet, she decides to post her own question in the forum so that she can get some help from some NASA data subject matter experts. So from the home page, she navigates over to the Post a New Question button. After clicking on the green button, she is prompted to enter her Earth Data login information. NASA uses the Earth Data login account as a security measure to prevent bots from spamming the site and as a way to gather metrics and statistics on how many unique users are interested in NASA data. If she didn't have an Earth Data account, she could easily create one for free by scrolling down the page and clicking the blue Register for a Profile button seen here. This student already has an account, so she enters her username and password, then clicks Login, and she's directed to the Post a New Question form. First, she fills out the subject, making sure to be descriptive so that others could easily search for this question once it's posted. She goes with the title, Australian Wildfires Visualization, and then she types her question. I would like to use MISR data to study the smoke emitted by the Australian wildfires that occurred in 2019 into early 2020. Can you please help me find this data? Before she submits her question, she has the option to tag her post if she would like. This is not required for question submission. If no tags are selected, no worries. A forum moderator can retroactively mark the post with any relevant tags. And what you don't see here is if you're a new user, you will be required to complete the CAPTCHA challenge to protect the site from spamming in order to submit her question. So, after submitting her question, a message appears on her screen notifying her that her question has been submitted successfully, but that it will need to be approved by a moderator before it is publicly viewable. She is told she will be notified when her post has been approved. In the interim, she is given the option to return to the forum to do some further searches. She can also change her notification settings on how she would prefer to be notified when a response is available. But when will her question be answered? The user support hours are Monday through Friday, 9 a.m. to 4 p.m. in the Eastern Time Zone of the United States. These are the hours that the moderators and SMEs will answer your questions. Please also note that these U.S. holidays are non-working days. And please be patient as a moderator tries to answer your question within 24 hours of you posting it, assuming that you posted during normal support hours. After the question is submitted, it will appear in the forum after a moderator has reviewed and approved it. We ask you to please be patient while waiting for approval for your first couple of posts. If you become a frequent forum user posting several questions, you will not need to wait to be approved each time. When the moderator cannot answer a question, it is forwarded to a subject matter expert or SME. The moderators and SMEs coordinate to find the information the forum user is seeking and then post the answer to the user's question. After a couple hours, the student receives an email that someone has responded to her post. It reads, you are receiving this notification because your question at Earth Data Forum was approved by a moderator or administrator. She can then follow this link to see her question on the forum. So she clicks on that link and returns to the forum site. She sees this page. The bell at the top of the page provides information on updates to her post. Here she sees the post was approved and answered by a moderator and reads, MISR satellite data is available at the new ASDC website here. I would suggest using the MI3 MANENS dataset because that shows the aerosol optical depth on a monthly timescale. Looking at November 2019 data, please go to this page to directly download this dataset. We also have a Jupyter notebook you can use to subset the spatial area you are interested in over the southeastern part of Australia. Please download the Jupyter notebook here, which also includes the user guides. So the student clicks on the link to the new ASDC website and gets a pop-up asking, are we sure we want to continue to an external site? After clicking on the green button, we are directed to asdc.larc.nasa.gov. Before we bid farewell to the forum for now, in summary, the forum has a few key benefits you can see listed here. We're happy to show you the forum today. Now, the ASDC welcomes you to our new website. NASA's Atmospheric Science Data Center has a redesigned website to better serve the needs of the atmospheric science community. The website's features will not only make it easier to search for data, but also provide a wealth of educational resources to enable users to learn more about atmospheric data. As a note, we are presently in the user acceptance testing phase of bringing this site online, and some features or pages you see today may look different in the future. We are now going to give you a brief tour of the website before we search for the data we need to visualize the Australian wildfires. From our homepage, you can explore collections of our data view our project catalog, and find what tools and services we provide. A user can also search the site by typing in keywords into this box here. If you aren't on the home page, you can find links to any of these pages by using this menu bar in the top right corner. For example, you can select data from the menu. There are many pages seen here, some of which we'll dive into exploring later. Moving on and scrolling down the web page to recent DAAC updates, you can see some of our latest posts. The news features show links to interesting user profiles, announcements of new tools and services, such as the launch of the forum we talked about earlier, and informative articles such as this article on the visualization of the Australian wildfires. You can find older posts by clicking the All News button here to see the expanded news feed. If you want more details, you can dive deeper into each news item by clicking on its title or on the Read More button. Once you are done reading the article, you can use the Home button here to take you back to the home page. Back on our home page, let's look through the website's menu in more detail. Here is the About tab, where you can read more about the ASDC, as well as find our contact information. The second option in the menu bar is Data, with lots of options on downloading data, including direct data download. The third menu button is Community. Here you can find a link back to the Earth Data Forum, as well as some frequently asked questions. Under Resources, we have a glossary of frequently used acronyms at the ASDC. We also have pages that teach you how to cite our data, showcase recent publications that used our data, as well as relevant links. Back on our home page, let's look more closely at these three white buttons in the middle of the page. Let's navigate to Explore Collections first. The ASDC has more than 1,000 archived data sets, which can be challenging to shift through quickly. So here are some filters by discipline to help you find the data easily. Here you can see the four main research areas of the ASDC. Say we're interested in cloud data, we can click Clouds and apply Filter and scroll down for the results. On the left, you see the data results as links, the disciplines, and spatial and temporal information. There's also a search feature here. Say you want data that is both clouds and radiation budget related. You can type that in there and click Enter. If you want to browse, you can click on All Collections. Going back to the home page, we navigate to Project Catalog. At the top of the page, you can see a list of our featured projects. These projects at the top are missions that are either newly acquired or currently ongoing. Scrolling further down, you can see the ASDC's entire project catalog shown here in All Projects. For each mission, we have the mission logos as well as the mission acronyms spelled out. And you can click on the links for more information. We now go back to the home page and click on Tools and Services. Our Tools and Service page provides more information on which tools and services are available. At the top, you see three featured methods for finding information or ordering data. The All Tools lists all available tools the ASDC has for you to use, as well as provides filtering. You can filter tools that only analyze, or tools that only deal with spatial data, or tools that allow you to subset. You can select all for browsing all the tools. For example, you may be interested in Esri ArcGIS tools, or you may be interested in series subsetting. Now let's go back to the home page. Do you remember our graduate student who was interested in studying the Australian wildfires? Let's get back to her data discovery story. Remember, the moderator in the forum told the student which data product to use. On this website, let's use the search function to search for that data product. The forum suggested using the Miser data product called MI3 MAENF. So we type that in the search bar and click on the search button. The search result gives us one link. Clicking on it leads us to the landing page for this data product, which has a nice description of the product as well as information about data distribution, spatial information, which is global in this case, and we can scroll down the page to get more resources and documentation and other general information about this product. But let's slow down for a minute because this is a bit overwhelming. So let's pause and talk more about the data itself. What does MI3MAENF stand for? Is it some kind of code we need to decipher? Well, yes, MI3MAENF is like a cipher, but you can crack the code easily. Every letter and number has a special meaning. The MI signifies it is a MISR product/mission. The 3 signifies a level 3 data product. The MAE means it is monthly and an aerosol product. The N signifies these files are in the net CDF format. The S in this collection name signifies a first look product, and first look products are produced within a current quarter and then reprocessed after the quarter ends into a regular product. So if you need MISR level 3 aerosols data that's current to today, you would use the first look. After the data is reprocessed and finalized, for example, you're going to see it without the F. So if you're looking for data from last summer, you would find the same data set name, but without the F at the end. This collection is considered to be at a level 3 product in terms of NASA's data processing level scale. Here you can see the different data levels from level 0 to level 4. Level 0 and level 1 products typically aren't visualized. They tend to be the more processing steps to make other data. Level 2 is typically swaths of satellite data. And level 3 are spatially referenced, meaning they are more user-friendly to visualize in either 2D or 3D. And level 4 involves using model data with the satellite data. Generally, level 3 products are the easiest for beginners to work with since they are spatially referenced. Now we go back to the website after our detour, hopefully feeling more confident about what everything means. It's time to actually download the data. We want to focus on the data distribution box on the right. You have 2 options here. Please ignore the Get Dataset and what it says below. We want to focus on additional options. In the upcoming months, this page will change slightly and we'll only have 1 direct data option. For now, click on the 3rd direct download option. After clicking on the direct download, you will be directed to the Earth data login page. I was already signed in, so it didn't ask me for mine. But you should log in using your Earth data credentials. So this leads you to the site with a lot of different dates. And this is our new tool called Direct Data Download. And it allows you to, you guessed it, download data directly without waiting for an order or an email to say it's ready. So please note these files use the American date convention of year, month, and day. Because this is a monthly product, there will only be 1 data file per month. So in this case, the 01 does not stand for day, but it stands for the data, only data in that month. So we know the Australian wildfire started around November 2019, so we'll scroll down the page to find that date. Once we click on that, it leads us to this page here with 2 files. We want to download the .nc or .netcdf file to our local computer. So go ahead and click on the .nc file, choose where you want to save it on your computer, click Save, and it should start downloading on your local computer. So now we have downloaded the file and we are ready to get coding. Before we jump into the last section of our demo, I have some final notes concerning ASDC's new website. So some cool new easy search capabilities, tools and services, outreach, and direct data downloads. We also have several upcoming projects that will be available on our new website. Data analysts at the ASDC have been researching innovative ways to use Geographic Information System, or GIS, to visualize and interact with atmospheric data. and airborne data users will have access to the new suborbital order tool that will allow users to easily search for and download gas and aerosol data. Keep a lookout for these exciting tools coming at you in the next 6 months. So in summary, NASA's ASDC updated website, asdc.larc.nasa.gov, makes it easier than ever to find the atmospheric science data and educational resources you need. We have listed some new features that we hope you will find useful in your exploration of NASA data. We hope you visit the site and do some more browsing after this webinar. Now that we have downloaded the data, let's try and visualize it. This is not always an easy task, so we are going to walk you through it step by step. Atmospheric science data can be visualized, analyzed, and understood using a variety of tools that span all skill levels. One of these methods is by using an open source web application called a Jupyter Notebook. Jupyter Notebooks are friendly to users from all levels, beginner to advanced, and are a way to create resources that contain code using programming languages such as Python, along with text, images, equations, and visualizations. The Atmospheric Science Data Center has user guides for how to install and get started with Jupyter on your machine for both a Windows and Mac operating systems, walking you through the download and installation process all the way to creating your first Jupyter Notebook. We have these guides available to download on our website. On the home page, click on the news story on the lower right called Australia Wildfires Observed by Calypso and Miser. Scroll down the page until you see in bold, download the Jupyter Notebook and user guides here. Click on here and you can save the zip file to a space on your computer. The zip file actually contains 4 files, one how-to guide for Mac users, one for PC users, the data file that we downloaded earlier, and the actual Jupyter Notebook file that we'll be working with today. So once you are set up with Jupyter Notebooks using one of our handy guides, you can begin using them to visualize a particular type of data. And continuing with our case study example that we've used in previous sections, let's go through a notebook pertaining to the Australian wildfires using the MI3 MAENF product we discussed earlier. This product contains aerosol optical depth, or AOD, data, which we will examine. Aerosols are tiny solid and liquid particles suspended in the atmosphere. Here you can see some aerosols in this visualization of summer 2017. Wind-blown dust, sea salt, volcanic ash, smoke from wildfires, and pollution from factories are all examples of aerosols. Satellite measurements of aerosols, such as the Calypso image from Calypso seen here, are based on the fact that the particles change the way the atmosphere reflects and absorbs visible and infrared light. Here you can see smoke from the Australian wildfires reaching up to 21 kilometers in the atmosphere. AOD is used to measure how quickly a beam of light decays as it passes through the atmosphere. The resulting numbers can give us information about the amounts of aerosols present in the atmosphere as well as their composition. I'm now going to walk through an example Jupyter Notebook. As a reminder, this is the same Jupyter Notebook you can download from the ASDC's website. At the top of the notebook is a micro-article, which is a few paragraphs explaining the story about the wildfires. This gives users the context and a bit of narrative about the story we want to tell. This is an important piece of the notebook as it sets the tone before diving into the code. We also have the image from the Calypso satellite in here for a nice visual for users and grabs their attention. To begin, we will need to initialize the libraries we need to support the Python functionality we will be using. Now we will click the play button, or this run button, up here to run the first block of code. While the block of code called the container is running, you see an asterisk between the 2 square brackets on the left. When it's finished running, you will see a number, which shows you the order in which the containers have been run. That's done, so now we will move to getting a data file so that we can extract information from it. This next block of code will store the file locally. We'll call the file stored locally on your machine for analysis. When it's done, we should get a message saying that the call was successful and you know it's ready. By the way, if you have this data downloaded on your computer, like I showed you how to do earlier, you can change this to use the files on your machine. We see our positive message, so let's dive into the analysis now. Now that we have a file, we use Python to ask for the particular parameter we are interested in, the aerosol optical depth, along with the geographic information so we can make sure that we are displaying the data over the correct location. The reason that we are asking for aerosol optical depth information in this way is because of how the file information is structured. To view the different information parameters inside a NetCDF file like this one, we suggest using an external software like Panoply, available to download for free online. So now we've asked for our data and we are ready to set up the actual visualization part. Let's create a map and specify that it should be over the Australia region, specifically over the southeast coast of the continent, where the majority of the wildfires took place. We can make a map as big or as small as we would like, and we can adjust other aspects of it, such as axis labels and the title, using different lines of codes here. So everything's set up, and we want to run the block of code so we can see an initial display of the aerosol optical depth data over the eastern Australian coastline. We click Run, and we should see something pop up below the box of code. So there it is. Now we see some data on a map of Eastern Australia. We also have some other tools related to the satellite of Miser and its different swaths. So here are the darker colors that you see. They're the higher amounts of aerosols in the atmosphere coming from the wildfire smoke. We could overlay this with red dots to say where the fires are. But you can see very high concentrations of aerosol in the atmosphere here. We can also continue to play around with the code to create the visualization best suited for our purposes. We can change color, scale, region, and even download more files to create different types of visualization, perhaps for individual days. Looking at data over multiple days or multiple months will give us an idea of how and where the aerosols were transported. The goal of sharing this Jupyter Notebook with you is so that you can customize it to suit your individual research needs. Are you more interested in visualizing clouds? Then look to download Calypso data using the same method. Are you more interested in the radiation budget? Then look to download series data from our website. Here we've listed some of the benefits to using a Jupyter Notebook. They can also be used as an education tool to share with students in the classroom, whether that be high school students or college-level students. They can be used as homework assignments as well, or class projects. We hope you find the Jupyter Notebook a useful tool and encourage you to visit their website here to get more information. Thank you for attending our webinar. I hope you found this workflow useful for your current and future research, learned something new, and were inspired to try our resources out in the future. We at the ASDC find it fascinating how NASA satellite data is monitoring the health of the Earth. The Australian wildfires were large enough to be seen by satellites in space. Scientists can use the information collected by instruments on satellites such as Miser to study the aerosols in the atmosphere. A step further would be to see how the smoke and particles emitted by the wildfire affected human health. There are many ways to explore this avenue of research. Today, we walk through a case study of using NASA data to monitor a major event, such as the Australian wildfires. Here's the workflow we went through, and we hope that you can use this many times to fit your research needs. So we started with a graduate student who had a question about data, and the student then went to the Earth Data Forum to search for and post data-related questions. The forum moderator pointed the student to the new ASDC website to download the data. After downloading the data, we showed you how to use that data in a Jupyter Notebook, which allows you to easily visualize the data. And the last step is sharing your science with the world. Once you have a visualization, you can share your science easily, such as within a story map like I did in this presentation. Please feel free to explore our story map and the websites we showcase today in your own time. I want to thank you for your time and attention. I also would like to thank our host, NASA Earth Data, and also the many people at the ASDC who helped make this presentation possible. Thank you again, and I'll hand this over to Jennifer.
Okay, great. Thank you, Danielle. At this point, we will transition to a final optional set of polling questions, and we'll give these about 3 to 4 minutes or so, and then from there, we'll move directly to the Q&A period. All right, thanks, everybody. We'll give these just a few minutes, and then we'll move over to the Q&A. Okay, everybody, at this point, let's transition to the Q&A period. And we do have our first question here. Give me just 1 second. Okay, the first question is there any possibility to access ASDC data through Python API options and generate the results without downloading the data?
We currently do not have that option available to the public, but we are working on that. We are working on Python APIs so that you don't have to download the data. So to be determined, but it's coming down the pipeline hopefully within the next year.
Okay, thank you, Danielle. The next question is, and this question was posed during the data discovery and data access demo for the MISR data. How does this integrate with the NASA Earth Data Search tool, or is this just a separate way to get the data?
This is a separate way to get the data. Earth Data Search, you will be able to find the same data there as well, but the difference is Earth Data Search is still working on their direct data download capability. So you could go to Earth Data Search, but you will put in an order for the data, and then you'll get an email saying that's coming soon through an FTP access, and they're getting away with that. So NASA's getting rid of all that kind of order tools, and so there's going to be more direct data download on Earth Data Search and our website. So our website is, for ASDC data. We encourage you to go there. Earth Data Search, you'll also find that MISR data on there, and all other NASA data as well.
Okay, thank you, Danielle. The next question is, you can use, well, it's really a comment and then a question. You can use the Jupyter Notebook for AOD Level 2 data, especially the MIL 2AD AE files. Do you have examples or tutorials that I could see that you could share?
Yes, we could. Give us some time to work on that, because my colleague Sanjana, she made a Jupyter Notebook to make a GIF of that GIF that you see on our front page is using Level 2 data. So she does have that. We don't have it public yet, but we can definitely make that public for that data set that you're talking about. We can make a tutorial easily. So, but just give us a couple days to get that done, and we can get that back to you.
Okay, great. Thank you. Let's see here. The other question was, is there a link to the story map? Or I guess, where will this link, this will be housed on the new website, Danielle, or where can a participant find the link to today's presentation, since it was not a PowerPoint or PDF?
Yeah, so we are planning on putting the story map up on a news feature. So we will have a news feature with all the related webinar stuff. So we will have the videos, we'll have the story map posted up there. So within the next day or so, we will have that up on the website for you to peruse, because we want you to look at the story map and be able to download the data and the Jupyter Notebook all in one place. So that will be coming in the next couple days.
Okay, great, thank you. The next question is, will data sets like MCD 19A2 also be available at asdc.larc.nasa.gov? I think that's referring to...
Can you repeat that again? What kind of file was it?
So it is, will data sets like MCD 19A2 also be available at asdc.larc.nasa.gov? And I think this is a MODIS data set, so I'll let you answer that, but it's, I think, available elsewhere.
Yeah, I don't know that we have any of those data sets here, unless someone else on the line can answer. That may be available through NASA Earth Data Search, or maybe Worldview.
They're actually available through the LP DAAC. So those particular data products are available. I'll put the link in here for you, and I can certainly follow up offline. Let me put that into the pod here. All right, are there any additional questions? And actually, I can follow up with this particular user via email as well afterward. I'm scanning to see whether or not we have additional questions at this point in time. So something to note, the EOS disk distributed active archive centers are discipline specific. So you heard about some data sets available through our ASDC DAAC today, but certainly there are a breadth of Earth system science data sets that are available across 12 of our distributed active archive centers, and I encourage you to check out earthdata.nasa.gov for additional information. All right, are there any additional questions? If not, just a couple points here. What we'll do, if there are no further questions, we will log off from the audio component. However, we will leave the virtual meeting space open for an additional 5 to 10 minutes. If you think of something, please feel free to jot that into the Q&A pod. We will share this with our speakers, the Q&A log, so certainly if they need to follow up offline with any of you, they'll be able to. All right. With that, I'd like to thank all of you for participating today, and I'd like to thank our speaker, Dr. Danielle Grumman. And our next webinar will be held on May 6th. We will not have a webinar in April. And our National Snow and Ice Data Center will be speaking. So if you stay tuned to the earthdata.nasa.gov site, there'll be an announcement in the coming weeks, or you could find information at our online Adobe Connect catalog, which is tinyurl.com, Earth Data Webinars. All right, thanks everybody. We appreciate your participation today. Take care now. Bye-bye. Thanks, Danielle.
Thank you, Jennifer. Bye, everyone.